Welcome to vCloud Networking Finally Explained. We're going to have some people probably joining us in the back of the room. Is it a loud echo in here, or is this just me? Just me. Loud echo. Okay, he'll fix that. We'll probably have some people joining us. Apologize for that. I guess they moved rooms. Everybody found us okay, though. Everybody went all the way upstairs and then came all the way back downstairs. Hopefully people won't get stuck in the ESX top thing, thinking it's networking. So my name's Mike DiPetrello. I'm the Chief Global Architect for pretty much all things cloud-related at VMware. But in particular, these days, I'm focusing really on the cloud infrastructure. So like vCloud Director, vSphere, and enterprise management as well. Today, we're going to talk about networking in vCloud Director. So just by a show of hands, who in here has used vCloud Director in some respect or played with it a little bit? All right, a good little number. And who in here has used vCloud Director 1.5? Maybe you're in the beta program or just snagged it illegally somewhere. Okay, perfect. So we are going to talk about stuff that's in vCloud Director 1.5 as well at one point in time in the session. So we'll put up the good legal disclaimer, what I'm talking about, may never see the light of day, blah, 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 all that good old stuff. All right, now, past the legal disclaimer to what we're going to talk about. We're going to go into a networking overview, which generally is going to talk about the different types of networks that we have in vCloud Director. We're going to talk about stuff like external networks, organization networks, vApp networks, network pools. We'll talk about some of the more advanced features that are in vCloud Director, especially with the vShield integration that we've been doing. And then we're going to talk about some example use cases. There is a Q&A session. I guess you can put it at the end. I like to put it throughout. So if you have questions while we're going along the way, please just raise your hand, shout out, just yell. We have microphones, but there's pretty good acoustics in the ballroom here. So just shout out, and we can answer your questions as we go along and move along here. Also, by a raise of hands, real quick, who in here is a foreign language speaker? Just so I know from, okay. Well, howdy. That's about my foreign language skills on the third day in Vegas. I can't do better than that. But I will try and talk a little bit slower. I am born and raised in the south of the U.S., but tend to talk like a New Yorker. So, starting with vCloud networking. So vCloud networking, there's basically three different levels of networking. You have external networks, you have organization networks, and you have vApp networks. Those are the only three things you're really concerned about inside of Cloud Director. The first two, an external network and an organization network, are set up and controlled by providers. Whether you be the IT guy setting up a private cloud as the provider, or whether you be a service provider setting it up for external customers, as a public cloud, the provider controls those two. They set up those two, and we're going to go into details on that. The third network, which is a vApp network, that's the only network that a user can actually create and control on their own. So that's a very important distinguishing remark. And we will go ahead and talk about that when we get there, and I'll tell you why that is. So we're going to start with external networks. These are very, very simple things. An external network inside of Cloud Director is basically anything outside of vSphere that you're bringing in, whether it's an internet link or a lab network or something else inside of your organization. You basically connect that to the vSphere platform as a port group, right? And then you present that up into Cloud Director. It's an external link outside of Cloud Director where VMs can go out and communicate to something outside of, vSphere proper. So that is an external network. Very, very easy to set up. Now you have to remember that Cloud Director, all its job is to take vSphere resources, standard vSphere resources, and basically abstract them, make them multi-tenant, which means that anything I do in Cloud Director, like set up an external network, all it's doing is going and talking to vSphere and using standard vSphere stuff. So standard port groups, standard virtual distributed switches, standard virtual switches that are out there. All of that stuff is done by Cloud Director, but it drives down in there. So if we look at an external network, for example here's a vCenter, a virtual distributed switch. I can't point both places at the same time. But you see it at the bottom of the picture. I have a port group that's on that, labeled EMCA Internet. Right? So this is just like some internet connection, for example, that I've attached to vSphere. I've put on this virtual distributed switch at this point in time. It has an uplink. And what I do inside of Cloud Director is I go inside of Cloud Director, I say, okay, select the virtual center that I want to use to grab this network from vSphere. And then I can see, hey, there's EMCA Internet. It's one of the port groups that I have defined here. So I just connect it to the EMCA Internet and done. right? That's an external network. That means I can now have VMs that can go and use that as a resource once I connect it with an organization network or a vApp network. So simple, simple, simple. It's probably the simplest part of vCloud networking as an external network. It's just connecting to a port group inside of vSphere. Now, in order for VMs to actually use that, we have to connect them to what we call an organization network. So these are inside of each organization. An organization network gets connected to an external network, and it allows VMs to now use that external network. Because we don't want the organizations themselves to see these external networks. These external networks might be shared between organizations. You might have Coke, for example, and Pepsi that are both using a shared internet link inside of a service provider model. Or you might have finance and HR that are using a shared management network. So we don't want them to see the actual external networks. What we want them to see is the organization networks. And I have a picture of this on the next slide, where we can basically connect these guys in two different modes. There's a public mode, which means that the organization network is going to be directly connected to that external network. So if I had Coke and Pepsi again, for example, they're directly connected. It's all layer 2 networking at that point in time, so they're going to see each other's traffic, right? Not a good model if you don't want everybody to see the same traffic. It's okay if you do want everybody to see the same traffic. There are reasons to connect a direct public network directly to an external network. For example, if you're bringing in an MPLS VPN or you're bringing in a particular connection for a lab network or something like that, then you can connect it with a direct connection if you know that it's just one organization that's going to be using that. There's also something called a private or NAT routed network. So the NAT routed network says, okay, go back to Coke and Pepsi. Now we connect them NAT routed mode, so a little vShield edge device gets deployed on that network link. And now it protects both of them. It has a firewall that's sitting there. It won't allow any incoming traffic unless you punch holes through the firewall. And it's also NAT routed, so no broadcast traffic comes through and all that stuff. So it's a way to isolate and let multiple people share that network link. And then the other option we can actually do is have a private or internal organization network, where we create this layer 2 segment, this organization network, but we don't connect it to anything. So VMs can communicate to each other, but they can't go out and connect to anything that's outside of the environment. All of this is backed by network pools, but we're going to talk about network pools in just a minute. Network pools are basically a way to give us layer 2 segments. So here's a picture. Picture's worth 1,000 words. So the external network, that EMCA internet, for example, this is our external network we created previously. And then you'll see this gray box around the organization. So that's the bounds of the organization. And in here, by default, so this is the vCloud Director interface, we have a vApp. Well, what we've done is we've created an organization network that's actually NAT routed. So this is where I said the vShield Edge device comes in, has a little firewall that sits there, so it's protected from anybody else that happens to be sitting on that external network. And I can attach VMs directly to this organization network. So this vApp number 2, for example, is connected to this organization network. It can go out. It can use this external network at that point in time. So we've had a vSphere port group that we made an external network out of. And then inside of each organization, if we want it to use this network, we have to create an organization network that we put the VMs on. So it's very important that you realize where the VMs are sitting. They're sitting on organization networks or vApp networks. You can see also that we have an organization network that we've created, a second one, that's internal, right? It's not connected to anything. It's not going to go anywhere. The two VMs can communicate that are plugged in there. But this vApp number 2 can also go out because he has that external. So this is a very common deployment. A lot of people like internal networks plus the NAT routed network, so it's the default inside of Cloud Director. But we could also use this little drop-down box and make it a direct connection. We can uncheck the boxes. We can do all sorts of advanced stuff if we hit the Advanced tab. But this is a very common setup inside of Cloud Director. That's why we made it the default inside of Cloud Director from a networking perspective. So any questions on what we discussed so far, sort of organization networks, external networks? None whatsoever. Perfect. We have one back here. Yeah, so good question. The question was, I can see it's pretty easy to get out of the cloud, right? If I'm this little VM here, like this vApp 2, I can go outbound. That's pretty easy. That's standard. It's NAT routed, and NAT translation works and everything like that. But how do I get back inbound if I want to use this, right? what do I do to come inbound into this thing? Do I need to use a VPN inside of there? Do I need to do, what do I need to do? So what happens is there's actually a couple different ways. We'll talk about VPNs later in the presentation. That is one option to come back into the organization. This NAT router, like I said, by default, it won't allow any incoming traffic, but it's a standard firewall. So I can go in and I can say, hey, open port 80, and let it in to this particular destination if I want to. So I can say any coming in, and port 80 goes to that particular VM's IP address. So standard firewall rules. I can also go ahead and I said, well, this guy has a private IP address back here, right? This vShield edge will have a public IP address. Like this guy could be 1.1.1.1 back here, and this guy could be, well, that probably wouldn't be a good private IP address, but he could have that. And then this guy could have like 10.1.1.1, for example. So if I wanted to come inside my organization, I can hit this 10.1.1.1, and I can do NAT mapping, where I say, hey, if you're coming in on port 80, then anything on port 80 that's coming in, always send it to vApp number 2, because that happens to be my web server, right? So I can just do a NAT mapping, where that one IP address that's on the external part of the vShield edge can go to anything. I can also give vShield edge here, and you'll see this a little bit later, a bunch of public IP addresses. So I can actually say from my external network, I have a bunch of IP addresses. I'll give 5 or 6 of those to that vShield edge. And then the user inside of the organization can actually go in and say, hey, I want 10.1.1.2 to be the public address for this particular virtual machine that's sitting up here. So then you just hit that IP address, and it always goes to that particular virtual machine. Yeah, you don't have to make your external space fit all the VMs that happen to be in the organization. If you had 100 VMs back here and you wanted RDP into all of those VMs, then you would need probably 100 addresses out here on the public side. Yeah, potentially. So you could do that. All right, so that is an external organization network, or an organization network connected to an external network. Any questions on org networks? They're relatively easy, relatively straightforward. So moving on, we look at this. What happens when we create this organization network? This is an isolated organization network. So an isolated network, remember, is not connected to that organization network. All it really needs to know is, how do I create this fictitious layer 2 network that we're just now making up, right? Because it's just this layer 2 segment with VMs that are communicating to each other. So how do I make that up? Do I attach, with port groups? Do I get a VLAN? What we actually do is we say, hey, go use what we call a network pool. And again, we're going to talk about network pools in a minute, but network pools are basically a pool of a layer 2 segments. So that anytime I go and I say, hey, create another network, I just go and grab from the pool and say, this is a layer 2 segment. Here you go. Now I can put VMs on top of it. Again, more on network pools in a minute. But I just choose a network pool, and that's it from an internal only network perspective. For that NAT routed network, I have to choose 2 things. I have to choose which external network I want to attach it to. So here's my EMCA Internet external network that I had previously created. And then I, again, choose a network pool to create that layer 2 segment. So pretty straightforward, pretty relatively easy, our organization networks. The third network that you can have, so we talked about external networks and organization networks. The third one, and the only one that a user can control, is a vApp network. So vApp networks are inside the organization. They're completely private networks. They can only connect to an organization network. That's the only option that you have, or you can not connect it to anything. Again, we have 2 options to connect it: public direct mode or NAT routed. So I could have an organization network and then put another firewall sitting inside there to go to a vApp network. So if I wanted to have, like a test lab inside my organization and a production lab inside of my organization and something else, then I can create all these fictitious networks inside of the organization. Oops, let me go back here for just a second. Like I said previously, this is the only network that an end user can create. And the reason I say that, if I flip back a couple slides from a picture standpoint, you'll see our organization is bounded and has these 2 organization networks in here. You'll see when I create the organization network, I get to see and choose which external network I want to create, I want to connect it to. It's not good to allow a cloud consumer or a cloud user to see all of the external networks inside of your company, right, or inside the service provider. You wouldn't want to give them that capability, because then they'll go and they'll just try and connect to random stuff that you don't want to give them access to. So again, organization networks and external networks, these two links that are connected to each other are always done by the provider. A user can't set up that link. Whereas vApp networks, a user can actually create those. All right. Any questions? Cool. So network pools. Network pools are probably the most complex part of vCloud networking. What a network pool is again, we're creating sort of these layer 2 segments. We have these VMs that are communicating to each other on basically an Ethernet pipe, right? And we just keep on creating them dynamically. We can let users come in and just create a bunch of vApp networks. Well, we need to tell them how those VMs can communicate to each other, because those VMs could actually be on 2 separate hosts. And we have to figure out how do we have that layer 2 segment, stretched across that layer 2 host. How do we isolate this thing? So there's 3 different methods that we can use to isolate. The first is a port group backed network. The second is a VLAN backed network. And the third is using something we call vCloud networking isolation, or VCDNI. So from a perspective, if we go forward in a slide, we have port group backed networks are essentially saying, okay, I have these 2 VMs. They happen to be running on different hosts. I don't know that from a cloud consumer standpoint. You would go in and say, I'm going to create a whole bunch of layer 2 segments, but in order to do that, I need to create manually port groups for them to be connected to. These port groups will be connected to these networks, these layer 2 segments that we have essentially. And when the VMs sit on those, they'll go down, they'll talk to that port group in that virtual distributed switch, which will go out into your physical infrastructure. But then in your physical infrastructure, you have to, maintain some sort of isolation there. So you'll typically go and create VLANs in your physical infrastructure. You'll typically go and, create some other isolation inside of there. The advantage to this is that it works really with any switch, right? You can use virtual switches, you can use virtual distributed switches, the Nexus 1000V, any type of switch that you want from a virtual switch perspective. The downside is you have to manually create each and every one of these port groups ahead of time, right? So do something with scripting, create all these port groups. It's not really all that dynamic from a cloud perspective. I don't typically see a lot of people using these. When we build clouds, there's a very limited subset of people that actually do port group-backed network pools. Because, again, they have to maintain all those port groups. They have to create all those port groups. It's just very, very time-consuming from that perspective. The second type of network group that is a little bit more dynamic is something called VLAN-backed networks. Now, VLAN-backed networks are kind of nice because now what I can do is, as a provider, I can just trunk a bunch of VLANs into the vSphere infrastructure, right? Give it a bunch of VLANs. And then I say, use VLANs 10 through 15, for example, that we see here, as my network pool. Now, they'll just sit out there in sort of the ether, right? And when I go and create a new organization network, what it's going to do is it's going to go grab the next VLAN, create dynamically a port group inside the virtual distributed switch. So you do have to have a virtual distributed switch here. It'll dynamically create a port group inside of there, assign it that VLAN ID, and you know that, okay, these 2 VMs that are communicating, they'll go down, they'll hit that port group. It's going to go through that trunk that I've created across that VLAN, and it'll land on that other virtual machine. So we just created a layer 2 segment, but we've done it dynamically. So as users go in and crank up vApp networks, or as you go and start creating a bunch of organization networks, you don't have to worry about anything other than running out of VLANs, right? So this is a pretty good solution, a pretty common solution. All I have to do to configure it is give it a VLAN range, make sure that I've trunked that into the vSphere infrastructure, and then give it a virtual distributed switch to go and use to create these port groups. So again, Cloud Director is going to dynamically create port groups on your virtual distributed switch on the fly as people are creating organization networks. So this is a pretty good solution because, again, it gets me out of having to statically create port groups. It does it all dynamically. The downside of this solution is that it uses VLANs, right? VLANs are limited. We only have 4,096 of them running around. Anybody in here use more than 4,096 VLANs inside their environment? Yeah, there's a few of you. Probably mostly service providers or really big telcos or really big enterprises and stuff like that. And for those guys that are using that, right, you probably do something like Q&Q. Who likes managing Q&Q? Yeah, none of the hands went up that time. It sucks. Usually you have this big spreadsheet, complex spreadsheet or something like this to map all these VLANs together and everything to scale out VLANs. So what we said is this is a nice solution for most enterprise customers and most sort of the medium-sized service providers that are out there. but you're going to run out of VLANs sooner or later inside of your organization. So we needed some other way to have these very high scale, very dynamic layer 2 network creation inside of the environment. And so that's why we created something called this is a demonstration of VLAN back. Let's go forward though. That's why we created something called vCloud Director Network Isolation. So VCDNI is, you could consider it somewhat a proprietary protocol from a VMware perspective. There's actually a new protocol that we're working on called VXLAN, which you probably heard announcements about this week, and we'll talk more about that in just a second. But what VCDNI said is, okay, I needed some other way to have a layer 2 segment created that VMs can communicate across hosts. We don't know where those VMs are going to run. We don't know when they're going to move or anything like that. So essentially what we do is we do something called MAC and MAC encapsulation with a network ID associated with it. So let's say I have 2 VMs, and this is where I could have used a better picture in the slides. Kamau. Kamau was my cohort for creating the presentation. What we end up doing is we say, okay, I have VM number 1 that's on this host over here, and I have another VM that's on a host on the other side. They need to communicate, right? Well, this VM on the first host, since we know where everything is going to run, it says, okay, well, I need to talk to, :02 over here, right? So VM number 2. What it's going to do is it's going to send that frame out. There's something inside of the hypervisor running called DV filter. Has anybody heard of DV filter? Raise your hands. Who's heard of DV filter? All right, good. So DV filter does a lot of things for us, but in this particular case, what it does is it catches these frames as they come through, sort of the hypervisor, the switching layer, and it says, okay, you're actually looking for VM number 2 over here. What I'm going to actually do is put another MAC address, a source and destination MAC address on top of this frame as it goes through, with the MAC address for the ESX host that's running over there. Because your physical switches, like if I just send it out there, your physical switches have no idea what, :02 is. They don't see :02. So we're going to actually give it the MAC address, let's say :03, of the physical NIC in the ESX host. That way when it goes out to your switching infrastructure says, okay, I know where 03 is. It sends it over to the 03 host. That comes back in. DV filter says, oh, hey, you're running VCDNI. It breaks it apart, says, oh, you need to go to 02. We'll send the frame on to 02. So it just does MAC and MAC encapsulation to figure out where that stuff is and move it across. Really slick little solution that's out there. I say it's sort of proprietary to VMware because it breaks a lot of things. A lot of things don't know what the heck this little VCDNI packet is, right, or this frame as it comes across. And it's like, oh, I want to do intrusion detection or packet inspection or something like this on this thing. And it goes, I have no idea what the hell that is that you just sent. It's a malformed packet, right? Kick it out. Let's drop it. So we needed some better way to do this. And we needed some better way also to do this across, long distances, bigger sites. And so we worked with Cisco for a while on creating a technology that's called VXLAN. It used to be called VDL2. So VXLAN you can think of as sort of the next version of this, and it allows us to do the same thing, basically a way to tunnel a layer 2 network across a layer 3 network, right? So this could go across sites, it could go across, an environment, wherever it needs to be, but that's our next way that we're going to be doing VCDNI. It's not there just yet, but it's coming soon to a theater near you. But this is how we do it right now, MAC and MAC encapsulation. Now, the downside of doing this with MAC and MAC encapsulation, other than, break some physical stuff that's out there, is you do have to crank up your MTU size because we are adding more bits into the frame at that point in time. So you have to increase it to at least 1524. But if you're doing stuff like video distribution or iSCSI or multicast or anything in your network or running MPLS, you're probably already cranked up to probably jumbo frames at 9,000. You're way overkill at that point. But you've probably already increased it to at least 1524. That needs to happen in your physical switching infrastructure. It also needs to happen in the virtual switch inside of the vSphere environment. So you need to increase the MTU size in order for this to work and not, completely crater the system. So questions on this before we move on a little bit on VCDNI. There's usually a ton. I'm sorry? Yeah, why couldn't we use GRE to do something like layer 2 and layer 3 tunneling? Very, very good question. So when we were looking at it, GRE typically doesn't end up running inside of the virtual switches. We could have probably implemented that in the virtual switch. But again, this isn't really layer 3 at that perspective. This is still a layer 2 and layer 2, right? So layer 2 and layer 3, like a GRE tunnel, you need sort of some layer 3 device. Now we could probably say, okay, go over and create it. The ESX management interface has a layer 3 address, right? But we want to just simply do layer 2, pipes that are going across. And so this is the path that we ended up taking. This technology actually came as an extension of our Lab Manager fencing protocol. So if you've ever used Lab Manager, who in here has used Lab Manager? Right, a lot of people. So it was pretty much an extension of that. We had already used that. We were familiar with it. We decided to implement this. And now we've gone and we said, okay, well, let's just invent a new technology, right? VXLAN that actually does better on just stretched layer 2 networks. You can still do GRE tunneling, but it's gotten old limitations around it. But it is, still used out there today. Good question, though. Anybody else have a question? There's one back here. I'm coming to you, don't worry. Yeah, I think what you said is if you wanted to maintain the same sort of fence mode inside of vCloud Director, this is what you use. The answer is yes, generally. Yeah. Yeah, it's very similar. All right. Any other questions? I think there was one back over here. Yeah, so the question was around how do we implement security? Like, the VLANs they're easy enough, right? Because we have VLANs that are sitting out there. So these are actually still secure for a couple different reasons, right? We're doing Mac and Mac encapsulation, which is going to confuse the heck out of it anyways, right? Anybody that tries to break in there. But we're also adding a network ID to isolate these things. So again, we're creating all these different layer 2 segments. We need to isolate those guys from each other, from broadcast traffic, from security perspective, a lot of different things. So we add a network ID to this as well. So we say, okay, this first layer 2 segment we created, its network ID is number 1. The second organization network that we create, it's network ID number 2. So on and so forth. And so we prevent broadcast traffic at that point in time. When it comes over and it's just broadcast to network number 2 devices. So we only send it to those VMs from a layer 2 broadcast perspective. From a security perspective, you can, think, oh, well, this is another layer 2 network. What about, traditional attacks on VLANs? Can we use, attacks on this? Like someone in my other session said, hey, what if I just inject a Mac and Mac encapsulated packet, or a frame, what will happen at that point in time? The good news is we know where the MAC addresses are at all times. We know who's sending it, where they're sending it from, and everything like that. So as it's making its way through the switch, if we see it hasn't come from over there, and we know that DV filter didn't send that frame over on the source host, we just drop it. We say, forget it. You're not here. So we can do some unique things because from a virtual switch perspective inside of ESX, it's not a learning switch. Right? It's not like your physical network gear that says, hey, I'm just going to learn some stuff. You can spoof MAC addresses on it and all that stuff, and I'll just learn where you are. We specifically create these ports on the port groups, right, and know what MAC address is there at all points in time. So we'll just drop stuff if it comes in, and we didn't know where it came from at that point in time. And that technology has been around for a while. Yeah, one more question here. Yeah, okay. So the question was, we've got these DV filters floating around. They know where the MAC addresses are because basically vCenter is managing the MAC addresses. What happens if you lose vCenter? Is that generally the question? Okay, good. It is a little hard to hear from the back of the room. So from that perspective, what happens is, so vCenter manages the MAC addresses when VMs get created, right? It hands those things out, makes sure MAC addresses don't conflict. If you lose vCenter, the networking infrastructure still works at that point in time because they're still talking to each other from a DV filter standpoint. They're still talking to each other, across that management network. Now, if you lose like all of your management networking, your physical networking, then you're in a worse shop, but then you can't communicate anyways. So, have a bigger, worse day. But losing vCenter doesn't stop this from working at all. Yep, another one. I'm not hearing everything you're saying. Sorry. Yeah, so if you lose vCenter, you don't have a backup of vCenter, which is a bad idea, and you can't restore it, and all these guys become isolated, does this still work? The answer is yes there. And the answer is when you come back and you do create a new vCenter and you pull these guys back in, then it knows about the MAC addresses. It won't hand out duplicate MAC addresses. So the vCenter piece is just to make sure that when you're creating a new VM, a new MAC address that gets created doesn't conflict with something else inside the environment. That's really vCenter's only role. It's just new VM creation, right? Other than that, you can have completely isolated hosts. You can have no vCenter inside of your environment. This will still work, still run. Because of the virtual distributed switch, the control plane is shared across the ESX host, ESX to ESX. So if you lose all your ESX hosts or you lose all your networking, that's the only time this really stops. But vCenter, you can turn it off today. I wouldn't recommend it for a long time, but you can turn it off today, have fun for eternity, but it's a useful tool. You might want to turn it on back on at some point. Because if you ever managed like 100 ESX hosts without vCenter, it's sort of painful. Yeah. Is the MAC address replicated between linked vCenters? Kamau, I don't know that. Yeah, I think the answer is yes, right? It's attached to the vCenter ID, yeah. So it's attached to the vCenter ID, that's right. When we create MAC addresses, they're based on a lot of different things to make sure that they're unique when we create VMs. And it's based on the ESX host control or management service console NICs, MAC address. It's partially the IP address that's in there is based on the hash. It's the ID for the virtual center that's inside the hash. So yes, I mean, if you had two vCenters that were linked together, they don't control the MAC, they don't share the MAC address information, but the likelihood of them conflicting is very, 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 very minimal. I've seen it happen. Huh? Yeah. Huh. Very interesting. Yeah, I've seen it happen. So he's saying in his environment, he has vCenters, a lot of different data centers, right? He lets vCenter generate the MAC addresses, a little off this topic, but he lets it generate the MAC addresses and he gets conflicting MAC addresses like 5% of the time, you said, duplicate MAC addresses. And I said, I have seen it in large-scale environments. Typically, it doesn't happen, but the statistics say it can still happen 99.4% of the, or 99.4% of the time it won't happen. Mm-hmm. No, actually, for the MAC and the MAC, you can still do it. He's saying he fixes it by just statically assigning MAC addresses since for the VMs. That'll still work with this, right? Because they'll have their statically assigned MAC address that you did from a vSphere perspective. When we do the MAC and MAC encapsulation, it's sending it to the ESX host NIC, right? So as long as your ESX hosts don't have duplicate MACs from a physical NIC perspective, which again, same kind of algorithm, right? They could, but typically they won't. As long as they don't have duplicate MACs, then it's just MAC and MAC encapsulation. It's just taking your static and your static MAC address that you have for your VMs, and we're simply putting on bookends the ESX. Yep. 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 Okay. Here's a deeper conversation, and it's related to this topic, but not off this topic. So I want to go into it in detail. So if you find me afterwards, we'll go into more detail on it. All right? I promise. I'm not trying to evade the question. I'm just saying we're gonna move on a little bit. We'll come back to your question in a little bit because we have more stuff. I want to make sure we get to everything here. Cool. So networks, VCD&I networks. Where were we here? Now that we went to this MAC and MAC encapsulation stuff. So we basically covered everything that's here. The one thing we didn't cover is all of this VCD&I traffic can go over what we call this transport overlay network, or this transport network. You can assign a VLAN ID to basically all of that MAC and MAC encapsulation traffic goes through a particular VLAN. So if you want to do stuff like traffic shaping on it or just monitor it or see what it is based on the VLAN tag or something like that, you can basically put all of those layer 2 segments inside of a VLAN to go back and forth. You don't have to. If you don't, it defaults to 0 for the VLAN, so it'll go across the standard VLAN that you have inside of your switching infrastructure. I think we covered everything else on there. So the vCDNI backed network pools will create a port group inside of your virtual switch. So you'll see that we have a static-minded network port here for the vCDNI traffic. And for this particular one, we selected our transport network to use VLAN 99. So that's why it used VLAN 99 when it created this stuff. So again, all of it is driving vSphere from that perspective. Now, the next thing I want to talk about is our advanced vShield integration. So who in here has used vShield? A little bit or a lot? Okay, cool. A little bit of the room. Good. So from a vShield perspective, we've done two things. We've added better firewalling. So we have 5-tuple firewall rules basically inside of there now. And we added a VPN service, all available within vCloud Director's user interface. So as an organization admin, I can go in, I can configure firewall rules, I can configure VPN services. So if we look at this from a VPN perspective, when I go into the VPN services for site-to-site VPN, I can enable site-to-site VPN, and it gives me an external IP address. So this is the external interface on that vShield Edge device. What this allows me to do is I'm a user, for example, in an enterprise. I want to connect to a public cloud or maybe another private cloud and VPN into that organization. This is your VPN question from before. You check this little box. You can go ahead and say, okay, I'm going to go and just plug this into my VPN client, my IPsec VPN client, and now your VPN tunneled into that organization. So you're basically on that organization network, right? And then you can just go and communicate with it at will. The other thing you can do is you can actually create tunnels between organization networks, from an organization network out to another network, between organizations inside of a cloud, whatever you want to do. So the cool thing about this is, this is setting up for a vCloud Director, organization-to-organization network, where I say, okay, HR and finance, maybe I want to keep them isolated from each other all the time, so they're in two separate organizations, they have two separate organization networks, but I do have an application that HR and finance both share, right? Payroll. So I need sort of the HR system over here that manages payroll to go talk to the finance system to make sure that we're not spending all the money on payroll, right? And communicate back and forth to each other. But they're in two separate orgs. So I can actually set up a site-to-site or organization, essentially, to organization VPN just for that particular VM if I wanted to. Or I can set it up for a collection of VMs to use. So this is demonstrating, an organization-to-organization network where all I have to do is just say, okay, here's the cloud URL, here's the organization I want to go to, here's my username and password that allows me to get into that organization, and then boom, it'll go and create that vShield Edge site or organization-to-organization VPN service. All self-service, pretty darn easy to get into from that perspective. But organization networks aren't the only thing that'll happen. This is what I was just demonstrating, org network to org network, basically inside of an organization. But I could also go, private cloud to private cloud. If I had two different sites, for example, and I wanted to create a VPN tunnel between things, I can actually do a site-to-site tunnel between those. I can also do, okay, well, I'm a vCloud provider. I want to go to some sort of VPN endpoint, maybe inside of an enterprise. Maybe I took my front end, for example, put it up into a public cloud provider, but my front end still needs to come back and talk to some, mainframe-based system or something that I still have in my enterprise. I can create a tunnel, basically, from my enterprise up to that public cloud provider to allow the transfer of that information without having to call up the service provider, set up some MPLS link, set up a, expensive VPN solution. I can just go in as the organization administrator, upload all my front end, say site-to-site VPN, boom, done, and it's happy, right? And set all that stuff up. So self-service, end-user-driven VPN configurations. Very powerful inside of the interface inside of Cloud Director. We also have, and it's, again, IPsec, so we do AES or 3DES encryption. You can show your little key, you can increase your MTU size, it's more sort of in the interface. So anything that supports that from a VPN perspective. We also now have 5-tuple firewall rules. So for the people that have been using Cloud Director from a 1.0 or 1.01 perspective, right, you remember our firewall was pretty limited. We basically said, okay, here's the IP address that you can go to, here's the port that you can go to it on, and it's open at that point in time. We didn't really have source, protocol, port, destination from an incoming, outgoing. So this works just like standard firewalls now. Rule set follows the rule set on down at that point in time. So this one's actually really, really, really nice. 5-tuple firewall rules inside of the interface. And then the last thing that we added from a vShield perspective was something called static routing. So this will allow you, if you need to go, specify a next hop, for example, inside of your network, you can go in and say, all right, here's a static route for this particular network. Go out. Here's your next hop on this destination. So more advanced networking from an end-user perspective, from a cloud consumer perspective now inside of vCloud Director, which is really nice. Any questions on sort of that vCloud? Yeah, you had one. Oh. So the question was, hey, we've had in the past issues connecting, VPN to VPN kind of things. Is, brands or anything like that, any recommendations? So we do have a list of sort of certified devices that we've tested in our QA lab and everything like that work. That's inside of the vCloud documentation, the vCloud 1.5 documentation that's coming out imminently. So you can look inside of there, or you can contact, any one of the cloud specialists or your local SE, and we can get it for you before tomorrow. When you can get it by yourself. Okay, so the question was, hey, you mentioned 5-tuple firewalling. Is that a stateful or stateless firewall? Was that the question? Yeah, so this is a stateless firewall. All right, any more questions about this? We have one in the back of the room again. Here we go for the back of the room. We need a megaphone back there. Yeah, that's a very good question. Hey, as I start to deploy all these networks and do all these NAT routed networks and everything like that, it's just going to be deploying vShield edges all over the place. Is there a roadmap to sort of consolidate the number of vShield edge devices that are floating around inside of my organization? That was your basic question, right? Yeah, so there is a roadmap to consolidate those things. Unfortunately, in a big audience like this, can't tell you directly when that's going to happen because of NDAs and all that kind of stuff. But if you find me afterwards or find your local SE and then he can get you in touch with me or one of our vCloud specialists, then we can give you more information, more details about that. But yeah, we do want to consolidate those things. I have been in organizations where, we haven't really deployed everything in the cloud yet, but we created a lot of networks. And they actually had more of these little vShield edge devices running around than real VMs that are actually doing something. So it does become problematic. IPv6 support? Yeah, so that's on the roadmap right now for vShield. Again, kind of an NDA thing, so we can't tell you specifically in a large audience like this, unfortunately. But we do have it on the roadmap for vShield. vSphere itself supports IPv6, has for a while. vCloud Director roadmap, kind of the same time frame as the vShield support for IPv6. So again, if you contact your local SC or something like that, then we can get in touch with you and tell you more specific than sometime in the future. Yeah. Mm-hmm. Yeah, he says the port groups that get created, like when we're going and creating. Yeah, so these port groups that get created dynamically, he said, they only come enabled with like one of the uplinks enabled, and we want to change the load balancing policy or maybe the order of them or something like that. So that's a very common question. Right now, there's two ways to do it. Well, right now, there's only one way to do it. Tomorrow, there's two ways to do it. So the one way to do it right now is to use port group backed networks and manually create those the way that you want to and scale all that stuff out, which is an ugly, ugly, ugly solution, right? The other way to do it tomorrow is we have something called callouts in vCloud Director 1.5. So basically, Cloud Director right now is sort of a black box. When it does something, you really don't know that it's done something unless you kind of pull it all the time and ask it and ask it and ask it. In Cloud Director 1.5, we have callouts. So you can actually basically have a passive call out and it lands on a message bus, any AMQ message bus, 0.9 or later. So you grab it off the AMQ message bus, and then you can go say, all right, it just created a port group. It triggered a message notification. I'm going to go use VCO, for example, to go and flip it into the order that I want to, the right order. So that's the solution that I'm actually using with service providers right now and with some enterprise customers right now, is the call-out feature to just go and just change that, because it is a popular request, to get it in a specific order with a specific NIC, blah, blah, blah. Yeah. All right. Any more questions on this part? Perfect. So we have better third-party distributed switch integration. I'll let you figure out who that is in particular. But there's only one of them out there right now. That's the Cisco Nexus 1000V. But now we have full support for Nexus 1000V. Before, it only supported port group backed networks. Now we've done better work with Cisco as a good partner of ours. And it supports Cloud Director supports the Nexus 1000V for VLAN backed networks and VCD&I backed networks as well. So it'll do the dynamic port group creation and everything like that. So full-on support, using Nexus 1000V to your heart's content with Cloud Director. And this is basically the same thing, just saying, hey, now you have a third-party distributed switch. You can use your existing tools. You can put port profiles up inside of there, do all that magic stuff with these dynamically created port groups that are out there. So this is sort of the final slide on use cases. So this sums up basically everything that we've learned in the presentation. Came through in a really wacky color on his new slide deck that he just gave us. So if you look at number 1 over here, we have, gosh, you can barely see that. We have a VM that's connected to an internal organization network. So basically, this internal organization network, remember, organization networks are created by the systems administrator, right? Not the end user, but the provider administrator, because they can get connected to external networks. So you create this organization network. We have this VM that's on this internal isolated network. Maybe it's like a little intrusion detection system or something that runs off and scans the back end of this network that we have over here. So there's a lot of reasons you could do this. We've had people create like workstations and go to lab networks and then just go into the workstation, sort of remote console into it. So a lot of different ways that you can configure that. If we look at number 2 over here, we have a multi-homed VM. Part of it's on this vApp network. The vApp network gets created by the end user. So an end user has come in, created themselves a vApp network. So it can talk back and forth to a couple VMs. Maybe this is a web server, and this is an application server in sort of a testing environment. So we also actually have it connected to an external organization network. So this organization network, set up by the system administrator again, is connected to our external network, and it's NAT routed at that point in time. So we could punch a hole through the firewall, give it an IP address, for example, on the external side of the vShield, and it could come down at that point in time, connect to our web server, go to our backend app server or database server. So that one's a pretty common setup. You'll see this a lot inside of environments when they start playing with things. The third thing over here, bullet point number 3, again, is these 2 VMs that are on this vApp network that's isolated, right? It's not connected to any real organization networks that can go anywhere. So the only way to get into these VMs from a networking perspective is from something else sitting on this internal organization network. But if you wanted to like remote or RDP or VNC or something or SSH into these boxes, you will not be able to do that, right? Unless you're on this box over here or maybe one of these 2 boxes. They can talk to each other, but like if you're on your laptop, there's no way to SSH or RDP or anything into those VMs because they're completely isolated from the outside world. The only way to see what the heck's going on in there is to open up the VMware remote console to it, which will still work. And then you can see in the VMware remote console, get in there and do activities and stuff like that. It's important to note, when you put them on that isolated network, it's isolated. You're not going to get into it at all. And then if we look at, before was back to our NAT routed thing, and we talked about 6, we also have an external organization network that's connected back to this external network, but he doesn't have anything on there right now, so he's sort of empty. We could put VMs directly on here, and then he's direct connected, so he'll go out and he'll be able to see anything else that's on this external network from a traffic perspective. Whereas this one that's isolated by the vShield Edge will only see traffic that's inside this organization network right here. He won't see the rest of that external network traffic because that vShield Edge is protecting him. And then the last sort of VM that we have down here, you can see we have another VM on this vApp network that's actually NAT routed. So we can have a vApp network that's NAT routed connected to our internal organization network, or we can have a vApp network that is direct connected, which is this guy over here. So both options apply for external organization networks, but also apply for vApp networks, that network or that public direct mode, and then that NAT routed mode. So this is pretty common, or not common, this is a complex setup to have inside of one organization, have all those different networks, but we just want to show you sort of everything that we've learned sum up inside of one particular slide. So with that said, are there any more questions real quick? Actually, I'll take your questions, but before you go, if you're bolting to another session, just a reminder, fill out the survey. They're pretty easy. You log in, you fill out all 5s on the right-hand side, you put my name on it, you hit submit, and it goes through. So thank you for your time. I'll be here for a little while, and then we're going to get kicked out in about 10 minutes, and I'll meet you outside if you have more questions.